If I can find the duster. I've got it somewhere. Oh, here it is. Every single gene in the sperm and egg is important. And here's the sperm, little tiny thing and a great big egg, but they only have half the number of genes. So when they mate and unite, you have a normal complement of genes, but every gene in our body is important. You know, I've got a long, funny nose like my father and my grandfather and my great-grandfather. I've got eyes like my mother, a bit fierce. I mean, we are who we are because of our genes, although 99.2% of our genes are the same as the chimpanzee, or vice versa. It's interesting, which means we don't really understand much about genetics. But the other interesting thing is we all carry several hundred genes for disease, like phenylketonuria, dwarfism, cystic fibrosis. Cystic fibrosis is my specialty. 1 in 25 of us carry that gene, and you don't know you carry it till you mate with someone with the same gene and you get a pair of genes that have cystic fibrosis. It's like blue eyes. They're recessive. You can't have blue eyes until you have 2 blue-eye genes. You can have brown eyes if you have a brown eye gene which is dominant and a blue eye gene. You don't know you carry the blue eye gene. Or 2 brown eyes. So here's a test. There was a couple who both had blue eyes and they had a brown-eyed baby. Where did the brown-eyed gene come from? You boys. Where?
It came from my grandparents and that.
No, darling. 2 blue-eyed parents could not have a brown-eyed baby, so that brown-eyed gene came from somewhere else. Maybe it was the milkman. Okay, so you know, once you understand genetics, you know a lot. Okay, so we all carry several hundred genes for disease, but we don't know we carry them unless we mate with someone, and I have to come and tell you, I'm sorry, but your baby has cystic fibrosis and may not live to the age of 10. That's the sort of thing that we have to do. So under no circumstances is it indicated to increase radiation in the environment, because we will be increasing the number and incidence of genetic diseases, of which there are now 16,000 or thereabouts described. Lots of them. All right? So that's just a little basic lecture in genetics. The other thing is that if radiation causes cancer, why do we use it to treat cancer? It's interesting. Well, rapidly dividing cells are very, very sensitive to radiation. That's why babies are about 20 times more susceptible to getting cancer from being irradiated than adults. Okay, that's why 1 X-ray to the pregnant abdomen doubles the incidence of leukemia in the baby, which is cancer of the white blood cells. But so cancers are very sensitive to radiation, and what we do is we isolate the cancer and we zap it with huge doses of radiation, hoping to kill all the nasty malignant cells. However, some patients who are cured of their primary cancer go on later, maybe 10, 20 years later, to get a second primary cancer, because normal cells around the cancer have been mutated. The regulatory gene's been damaged. But that's okay, you've been given another 10 or 20 years extra of life, and anyone would accept that. Why do we use radioactive elements? Radioactive elements in medicine? Well, you often get a lower dose from having a drink of radioactive material, which is a very short-lived radioactive element, than having a normal sort of X-ray like an intravenous pyelogram. And these materials only last a short time, and you don't need a nuclear reactor to make them. And that's what they say, oh, we have to have leukocytes for medicine. But you can make all the materials we use in medicine from a cyclotron that makes no radioactive materials. I think that they built leukocytes because they want to make bombs, but I'll get into that later. Now, I'm not sure. Whiteboard cleaner. Does this work?
Yeah, it does.
You just spray it? It probably is. I'm not going to look at the active ingredients. Yeah, that's not bad, eh? All right, so now you've had your basic lesson in radiation biology, and we'll go on to the rest of the fuel cycle. So, can I flip it over?
Yeah, it's going to be much better outside.
Well, yes, at least there's nothing on it.
And I'll be outside.
Thank you very much. That's what I was hoping you'd say. All right. Now, so the uranium is mined and lots of CO2 is produced, and then it's all crushed with big crushers. More fossil fuel, more carbon dioxide, and then, as I told you, the uranium-235 has to be enriched to 3%. So we send all our uranium over to Paducah, Kentucky in America, where they have an uranium enrichment plant. This is converted to a gas, uranium hexafluoride, which is a global warming gas and also very corrosive and very dangerous. And that gas is forced through a bank of micropore holes. And on one side stays uranium-235 and the other side gets the 238. So that's how it gets enriched. It's a very energy-consuming process, and in America they use 2 huge coal-fired plants to generate the electricity to enrich the uranium.
Yes.
Yet Howard will say, nuclear power has no emissions. And I really get very fed up with politicians who either lie or who are scientifically ignorant. And we've got a few of them around, including George W. Bush, who says the same thing, and Dick Cheney. So two coal-fired plants, more CO2, and there are more global warming gases produced here, but I won't tell you how. Now, the uranium is then made into little pellets like chalk, ceramic pellets, and packed in fuel rods 1/2 inch thick and 12 feet long, and they're all taken along to a nuclear power plant, which they want to build near here, or Howard does, and 100 tons of uranium is packed into the core, submerged in water, and there are moderating fuel rods which, when carefully and slowly pulled out, the uranium reaches what's called critical mass, because the uranium atoms are unstable anyway, and they're very heavy, and they are always emitting neutrons. So when you pack the material in very closely together, the neutrons reach what's called critical mass. And that's what you get in a nuclear bomb explosion, like Hiroshima. But this is a controlled criticality, and it doesn't explode. But tremendous heat is produced as the atoms crack and break apart and produce 200 new elements, none of which ever existed before man fissioned uranium. And they're all very carcinogenic. The uranium becomes 1 billion times more radioactive in a nuclear power plant than it was initially. 1 billion times. And a nuclear power plant, thank you so much.
I just swapped pens.
This is good.
Okay.
A nuclear power plant contains 1,000 times more long-lived radiation than 1,000 times more long-lived radiation than a Hiroshima bomb. Okay?